Hello. For class 18 on Monday, I made this short introduction video. We are going to learn two main reactions, two main concepts as well. The first one is the idea that we could get a non-Markovnikov alkyl halide. Let me remind you what Markovnikov and non-Markovnikov mean. We saw that in chapter 6 or your exam 2, if we take this alkene that's not symmetrical, meaning that it depends where we put the H and the OH, in this case for a hydration, we could either add the H and the OH in a Markovnikov fashion or a non-Markovnikov fashion. And so each carbon, as you remember, gets something. You cannot forget what you learned for exam 2. We're going to be using these concepts again in exam 3, exam 4, and the final exam. So it's pretty helpful to review constantly what you've learned in the past. We have our carbon skeleton, and we have our two green dots, and we add an H and an OH. We hydrate. And in this case, the OH goes on the more substituted carbon. We learned that we could do the opposite, or we can put the OH on the other green dot, and that looks like this. If you remember the name of this reaction, you'll know that it's called hydroboration oxidation. Hydroboration oxidation. And that makes an alcohol in a non-Markovnikov fashion. Still, in exam 2, we learn how to add HBr and HCl in a Markovnikov fashion. And so we have this, Br goes there. Remember, both carbons got something. The carbon at the very end, this terminal carbon got the hydrogen. We added an H and a Br. In class 18, we are going to learn how to do this alkyl halide synthesis in a non-Markovnikov fashion. I'm not going to tell you the reagents here. Let me just put here class 18. But I will, you could probably guess what the product is. I got to make this in a non-Markovnikov fashion, meaning that I'm going to put the Br on the other carbon. Resist the temptation to put the Br here. Instead, you're going to put the Br at the end, right here. Okay, take a look at these two. Okay, the difference. Take a look at these two. We're going to learn the reagent to get the non-Markovnikov alkyl bromide. That will be reaction A for class 18. Reaction B for class 18, we're going to make alkenes. And I'm not going to show you the reagent yet. Okay, let's put here class 18. But let me point out what you should know going into the class. What you should know going into the class is that we're going to learn a rule called Zaitsev's rule that tells us if we make a mixture of alkenes, how do we pick the major product? Before I talk about picking the major product, let me give you a clue on how to get the alkenes. Okay, let's start at the starting material. We have an alkyl halide. And please, before class, know how to label the alpha and the beta. The alpha carbon of an alkyl halide is the carbon that's connected to the bromine. Any carbon that's connected to the alpha is called beta. We have two beta carbons here and here, and depending which one we use, we are going to get different products. And in this reaction that I'm not going to show you the reagent, and I'm not going to tell you the mechanism right now, but in this reaction you form alkenes. You form the alkenes, the double bond between the alpha and the beta. So here I have one double bond to the left of the alpha, and here I have one double bond to the right of the alpha. I just realized that it is possible to have cis and trans, and this is making it too complicated. So let me make this symmetrical. Not symmetrical, but let me make it so that we do not have cis or trans for this double bond, but we do have cis and trans for the second one. What do I mean? See how this one is trans? You do form the cis and trans isomers in these cases. Now look how I labeled the alpha and the beta. Alpha, beta 1 on the left, beta 2 on the right. Here the double bond is formed between this alpha and this beta. And for this one here, I chose the other beta, the beta on the right. That is definitely trans. And so you will also have to make the cis if they're cis-trans isomers, if it's possible. Okay, so let me show you again the alpha, and this was beta 2. I do not have cis-trans for our first alkene here because that double bond is, as you know, neither. Lastly, and maybe just as important as everything else I've said, Zaitsev's rule says this: if you make a mixture of alkenes, the most stable alkene is the major product. We call that the Zaitsev alkene. The most stable alkene, let me underline it, is the major product. So where's the most stable alkene? Yes, tri-substituted. Oh my goodness. Look how many concepts that you have to remember from previous modules, from previous exams, right? Stability of alkenes, tri-substituted. Cis and trans, okay? You know how to convert the trans into cis or vice versa, or know that your double bond is neither. Up here, Markovnikov versus non-Markovnikov, whether you make an alcohol or an alkyl halide. We're going to go over these concepts in class 18. Let me zoom out. And then there's a little bit of a treat. I think it's a treat. If we finish, or if we get through the handout in the parts that I expect to get through, we're going to have a third section called synthesis, where we are going to learn how to finally start designing syntheses, how to go from a cheap starting material to a more complex, maybe more functional target molecule.